In the name of Allah, we have to start session 4 today. Welcome everybody. My name is Mohamed Zakzouk. I'm working as a research assistant for the National Authority of Remote Sensing and Space Sciences in Egypt. We are going to give a presentation on open source model for monitoring oil spill. The research is part of NARSSS project, as my colleague introduced before. We are working under the GEMS and Africa projects funded by the European Union and coordinated by the African Union. The research is interested to give more studies on how to detect oil spill along the North African coast. We are working under the supervision of NARSSS co-chairman, Professor Islam Abul Majd, and from Suez University, Professor Ilham Ali. Going to the next slide. The content of today, we will give a brief about the oil spill problem and the current state of the art for remote sensing technologies available to detect the spills regarding the optical sensors and sensitive aperture radar. Then we will have a look on the open source solutions used in our developed model to do the detection and some of the validation cases and success stories. Final remarks will be given. So going to the next slide. We define the oil spill problem as the release of liquid petroleum hydrocarbon into the environment. It may be on land or on marine environment, but we are interested in the marine one. It may be from accidental releases, such as the petroleum platforms and tanker accidents, or it may be intentionally done from the ship discharges. From time to time, ship discharge amount of the used oil, lubricant oil, and other types of oil into the sea environment. And that part of the sources represent the most important source. The highest ratio goes for the ship discharges, which represent 45. So it needs more attention, the most important source for oil pollution in the marine environment. The problem of oil spill is very serious as it's very fast in spreading and can cover large areas. The problem lasts for years and leaves the environment very difficult to remediate. You have to do multiple operations to clean the environment. So if we have a look on the Mediterranean Sea, that is a density map for the oil spill happened in the period from 1999 and 2004. Nearly the north part along the European coast is the most affected, but also here in Egypt, we have a very high spot, and along the coast, the part for our countries, our North African countries, is affected with the problem. So from our cases, we will explore more in Egypt. Egypt has one of the most important marine routes, which is the Suez Canal, connecting the Mediterranean Sea and Red Sea. And that is the marine traffic density. Here in Egypt, we have very crowded traffic routes along the Suez Canal, and Port of Alexandria and Port of Damietta also have main traffic routes. So we have a high potential for occurring oil spill from time to time along these navigation routes. Remote sensing is considered one of the most cheap solutions to observe or to detect oil spill regularly. You can scan very large area every 2 or 3 days at low cost. And currently, we have open sources for getting data, such as the European Space Agency and the NARSSS product. Mainly, there are 2 technologies to detect oil spill, which are the optical remote sensing. Regarding the visible infrared and thermal infrared bands. Each kind of band had specific characteristics for monitoring oil spill, but the most common in use are the microwave radar imaging because of the ability to work day and night and not affected with the cloud cover. So it's more common in use, as we will see in the next slides. For the first part, we have done detection using the optical characteristics of the oil, and to create our library for the oil spill signature. We have made the virtual accidents and try to get the spill characteristic, how it appear in the image. And from this result of the experiment, we done some processing on one of the detected cases on the 27th of June 2017 near Port Said. This patch was clearly detected as very dark area in the water, which give high potential for oil spill. So clipping this area and observing the profile, spectral profile between dark pixel and pure water, we could see that the dark pixel have lower reflectance. That is because of the oil presence. And using unsupervised classification, we could split the two layers, oil and not oil, and get the final layer as a product we can give for the environmental agency and calculate the area of the spill and other surface parameter. But it's usually the optical remote sensing is not appropriate for using, as most of the earth, as we know, have clouds. Most of the surface on land and water have clouds. So the application needs another technology, not affected with cloud, which is the SAR imaging based on radar waves. We could see for that image the difference between the optical and the radar image for the same area on Port Said, that is the north exit of the Suez Canal. Here, the same area at the same time, but radar waves are not affected with clouds, so we have clear image to detect oil spill if present. That is what I mean. For the same area on the date of 4th of October 2014, we could clearly detect one of the oil spills here using radar images. The basic physical principle behind how to detect oil spill, the spill damping, the capillary waves, and the giving low backscatter to the satellite. So it appears dark in the image surrounded by bright area. Here we have the dark area, which is give a high potential for oil spill, surrounded by clear surface of water. So doing processing, which is the topic of today, the developed model to detect the oil spill, we do some pre-processing, we get some calibration for data and geometric correction, speckle filtering, which is a problem with the radar images caused from the destructive and constructive interference. We have to do speckle filtering and remove the land area. We are only interested in the seawater area. Going to the next section, we do the clustering or classification, removing the oil layer based on a threshold of backscatter. We define 2 decibel or 3 decibel to get the oil layer, and finally do the mapping. We get the output layer as the final product on GIS format. Regarding the technologies we have used, we are using open source tools such as the Sentinel application platform called Snap. We have built that model for reading the raw data and getting final product. And the next stage is done on QGIS, also getting raster data to convert for a final map. We have built that model, so that is all our story to do the processing. And we can see the results here. Firstly, we start with raw data. After pre-processing, we can get very sharp edge based on the threshold between the dark area and the clean seawater area. We can get that masked layer, and we can compare with the original image. Finally, we can produce that kind of maps to give the oil spill map for the accident happened. Regarding the validation of oil spill is not an easy task. As you know, oil is very fast in spreading. So if you have an oil spill and after 6 hours, if you have a field check, you can difficulty get the same location for the accident in the marine environment. So we have used another trick, which is getting information about larger accident and going back to our satellite images to compare. Here on the 11th of October 2019, one of the main or the very large accident happened to that oil tanker, which can hold up to 1 million barrel. The tanker had an accident and gave some release to the environment of the Red Sea. Going back to our satellite images and doing the processing using developed model, we could detect that very long accident, nearly extending over 500 kilometers, which is very long. And that proves that our model could detect the accident clearly. So we have done some validation. Another case helped to validate our model, which is a moving ship have been detected near Alexandria city in Egypt. If we have a bright spot followed by long tail of dark area that give a high alarm for oil spill from a moving ship. So going back to the data of ship navigation from AIS data systems, we could match the profile of the spill, of the detected spill and the nearby moving ships. Here we have excellent match with one of the routes, and we could get the information about the ship or the data about it and make a report for the environmental agency here in Egypt. So more of the success stories. After validating the model used, we have done more scan on other areas in Egypt. Here is one of the refinery in Egypt called one of the refinery at the Suez Gulf area. We have observed frequent spills from the refinery to the environment of the Gulf, and that proved that that area needs more concentration and more temporal resolution to detect the spills from that location. We have nearly processed the 3,000 of satellite scenes and detected 273 cases, which is a very large number along the period from 2017 to 2019, 3 years of processing. So we have a very large number of detected cases. Here we can see an atlas for the detected cases along the Egyptian coasts, the Mediterranean Sea and the Red Sea. And here is the zoom for the detection area. We have detected each case and calculated the area and the number of patches appearing, and the data source used is Sentinel-1, one of the European Space Agency product. And here is the city of the near product. Having a look on all the cases, we have done 2 maps, one for the Mediterranean Sea, one for the Red Sea, and all the cases. Here is the most affected area, which is Port Said, and for the Red Sea, Ras Gharib is the most affected in Egypt. So to have a more analysis on the spot areas, we have done frequency map. Frequency maps means how many times the accident has repeated for a certain area. Each pixel has number, how many cases happened here. So here is the red dot at the area near Port Said, which is the most affected in Egypt during the 3 years of study. We have more than 15 cases at that location. And for the other area on the Red Sea, which is Ras Gharib, is the most affected, but with a degree less than Port Said. So that is considered as a very strong base to continue our studies and focus more on these 2 cities. So the model succeeded to give us an alarm for which areas in Egypt are more affected, and applying on our partner companies on Tunisia, Algeria, Morocco and Mauritania, these countries have the same technology to do and detect the most affected city. So it's considered as a success for our teams. Finally, we have tried to combine both the SAR or radar images and the multispectral data to compare the cases. How can we use both technologies, providing more temporal resolution. Here, one of the accidents could be detected on the radar images, and after 5 hours, we have another image, but not multispectral. Difference between two images are 5 hours. So mapping both two images, we have here the first detection, second detection after 5 hours. That gives us an idea about how spill spread in the area, how spill area changes. So it's considered as a milestone in our research, how to do numerical modeling for the moving spills from time to time. Till here, we can conclude that North African countries experience a serious problem of oil spill and needs to be monitored from time to time frequently. SAR and open source solution has been employed to fast detect the problem and alarm the agency for the problem to give fast alert. And also we can use optical remote sensing as an auxiliary tool. Even we have multiple clouds, but still optical remote sensing can provide another auxiliary tool with the radar imaging. And ship traffic data have been used to verify which ship is responsible for the accident. As we have seen at the beginning, the ship discharges represent the most important part of the oil pollution problem in the marine environment. So we have to use the navigation data of ship traffic to match which ship is responsible, to make fines and give alarms for the environmental agency to fast clean the area and give remediation for the environment. Finally, I'd like to acknowledge all our partners to do that research from the GEMS Africa, European Union, and the African Union. Also, our colleagues at NARSSS and our partners from Morocco, Mauritania, and Tunisia, and from the regional organization of SIDARI. Thank you all. Here our contact information, and you can visit our website for more case studies and for more information on the topic of study. I'd like to thank you all for your patience. Thank you all. Thanks.